Have you ever wondered what makes a wind turbine blade strong enough to handle a hurricane? Or how a tennis racket can be light enough to swing at lightning speed but still not shatter? Well, the secret isn't just in the shape or the design, it's actually woven right into the fabric of the material itself. Let's dive into this hidden world of super strength.
So to get us started, here's a little riddle for you. How is a Formula One car, something built for insane speeds and punishing G-forces, anything at all like a satellite that has to survive the freezing, empty vacuum of space? I mean, on the surface, they couldn't be more different, right?
And there it is. The answer is all about a fundamental challenge in engineering. For both of them, every single gram matters. But at the same time, they have to withstand just unbelievable amounts of stress. It's that classic problem. How do you get ultimate strength without getting bogged down by a ton of weight?
And that brings us right to our first section, strength without the weight. I mean, this is the core problem that engineers have been trying to crack for decades, and the solutions they've come up with have totally changed modern technology.
So what's the solution? Well, it's actually kind of brilliant. It's not one single solid material. Instead, it's millions and millions of tiny, powerful strands called reinforcement fibers. You can think of them as microscopic muscles that give these modern composite materials all their superpowers.
Okay, so how do you go from these tiny little strands to something you can actually build a race car with? Let's jump into our next section and see how these things go from a single thread to a high-tech fabric.
It all starts right here, with something called a filament. This is the absolute smallest piece of the puzzle, the basic building block. And honestly, the best way to picture it is to think of a single strand of your hair. It's incredibly thin, right? But when you bundle a bunch of them together, they get remarkably strong.
Now, nobody's working with single filaments. That'd be impossible. Instead, they're gathered into this untwisted bundle called a tow. And this is where you get that K terminology you might have heard about. So a 3K tow, that's 3,000 filaments. A 12K tow is a bundle of 12,000 of those individual strands all together.
From there, these tows basically get treated like giant threads. They're put on these huge industrial looms and are literally woven into fabrics. And this weaving part is so important because it gives the final material strength in multiple directions, usually up and down and side to side.
But of course, not all fibers are the same. You know, depending on the job, you need a different kind of hero. So let's meet the fiber superstars. Each one has its own unique set of talents.
The two big players on the team are glass fiber and carbon fiber. Think of glass fiber as the reliable, affordable workhorse. You see it in everything from boats to circuit boards. Carbon fiber, though, that's the elite performer. It's way more expensive, yeah, but it delivers absolutely superior strength and stiffness for the really high-performance stuff like aerospace parts and Formula One cars.
And then you've got the specialist, Aramid. Most of us know it by its famous brand name, Kevlar. So if carbon fiber is the strong, lean athlete, Aramid is the toughest nails bodyguard. Its superpower isn't just pure strength, but incredible toughness and impact resistance. It's why this is the stuff they use in bulletproof vests.
So let's put some numbers on this. How do these materials stack up in just raw pulling strength? You can see E-glass is really strong. Kevlar is even a bit stronger. And then standard carbon fiber, well, it leads the pack. The bottom line is, all of them are unbelievably strong materials.
But here's the kicker. Strength is only half the story. The really crucial part is their strength for their weight. So take a look at this density chart. Remember, lower is lighter. E-glass is actually the heaviest of the three. Carbon fiber is a good bit lighter. And then look at Kevlar. It's the lightest of them all. It's this combo, what we saw in the last slide and this one, that makes these materials just so revolutionary.
All right, so we've got our woven fabric, made of these superstar fibers. But a pile of fabric isn't a race car wing, right? You've got to hold it all together. And for that, you need to add the final glue, which in the world of composites is called a resin.
Now, for high-end manufacturing, this stuff often comes in a super convenient form called pre-preg. It's a simple idea. It's the fiber fabric that has been pre-impregnated with a special resin. The resin is kind of in a semi-solid, tacky state, which makes it perfect and ready to be laid into a mold. And making it is this really precise process. First, they spread that resin into a perfectly even, paper-thin film. Then, the woven fabric is carefully pressed onto it. After that, they apply heat and pressure to make sure the resin gets into every little nook and cranny and soaks every single filament. And finally, the whole sheet gets chilled down. That stops the chemical reaction and gives you this stable, easy-to-handle pre-preg material that manufacturers absolutely love.
Okay, wow, we've gone all the way from a microscopic filament to a high-tech, ready-to-use sheet. So let's just step back for a second and look at what all of this builds and, why this whole process matters so much.
I mean, this whole journey is what's so amazing. Starting from microscopic filaments, picking the right fiber superstar for the job, and then assembling them into these ready-to-use sheets. This whole systematic approach, it creates the hidden backbone of pretty much all modern high-performance technology, from the planes we fly in to the bikes we ride.
So we've seen how these fibers are pushing the absolute limits of what's possible today. And that leaves us with one last, really exciting thought. If this is what we're building now, what currently impossible things will these materials let us create tomorrow?